Let's talk about chapter 2.4, the product and quotient rule. The first question is often, why should we care? Well, we've talked about compartment models in pharmacokinetics, where medicine is moving from like the stomach to the gut and to the blood and to the lymph and stuff. And we saw a curve like this. It's kind of like a bell curve, but it definitely starts at 0, 0, which statistical bell curves don't usually. So it increases, then it kind of tails off, but the tailing off takes longer than the rising. We've also talked about like if your car hits a speed bump or a pothole or something and your suspension bounces up and down for a while. This can also happen in other contexts, like if you try to move a robot arm very quickly and stop it real quickly, it might actually kind of oscillate as it stops. And here's some formulas that model those things. A surge curve as t to some power times e to the minus t. And sine of some frequency or cosine times some kind of exponential decay. And we might want to take the derivatives of formulas like this. If this is position, we might want velocity or acceleration. We might want to ask how fast is the medicine changing here. So we want to take derivatives of formulas that involve one term and another term multiplied by each other, but neither term is constant, so we can't use the constant vertical multiplier rule. So that's where the product rule is going to come in. Let's ask, what would we hope? What would be the simplest way of taking the derivative of a product? Take a sec to think about that. You're probably hoping, like I am, that it would just be like distribute the prime. You get f prime times g prime. It's always a good idea in math to say, what's the simplest this could be, but then go check it. So you could go check that on Desmos, make up a function f and a function g, take the derivative of their product, take their derivatives individually and multiply them, see what you get. And I think I prompted you to do that in a different video. Let me try making something up that will be fairly simple. So let's try f of x equals x cubed, and g of x equals x to the fifth. Let's practice real quick. What is f prime and what is g prime? Hopefully you got 3x squared and 5x to the fourth. So let's try this two different ways. Let's say the being careful way and the trying our hopeful formula way. So being careful, I'd say f times g is x cubed times x to the fifth, and still take the prime, and then see if you can take the next step here to simplify that. We get x to the eighth prime, which would be 8x to the seventh. And we're pretty sure that works. We're pretty sure about each step here. Our hopeful formula way would be f prime times g prime. So that would be 3x squared times 5x to the fourth, which would be 3 times 5 times x squared x to the fourth. And just this once, maybe we'll simplify 15 times x to the sixth. And we did not get the same thing either on both sides. And which way do you think is better or true? It turns out that this is right. And sadly, this did not work out. So apparently the product rule for the derivative of a product is not just take the product of the two terms. So in our next video, we'll kind of derive what it is based on a silly little situation, but at least it's simple.